Alright, so we are working with the function f of x equals x squared minus 4 over x minus 2 near the value x equals 2, which is where this function is undefined. Now, just a little bit about the concept of what we're going to be working with here. So let's take a number line, for example. Goes forever in both directions. Now, our target is x equals 2. That's what we're interested in looking at. So we start with x equals 1 and x equals 3. Those are values that are evenly spaced to either side of our target. And they're whole numbers, integers, so they seem to be probably where we begin. They're the closest numbers you'd probably think of. Of course, there are fractions and decimals. The thing to realize is that as small as this range of values might seem, there's actually an incredible amount of stuff going on in between those. It's all a matter of perspective. It's all a matter of how zoomed in you are. 1 and 3 seem very close to 2, yes. But are they really? What if we were to take this section of the number line and blow it up? So that 1 was all the way over here, and 3 was all the way over here. Suddenly there's a lot more space in there to play with. On the original number line, it doesn't make sense to talk about the decimal values, or rather we can, but they're hard to mark. If we wanted to find, say, 1.1, it would be very, very close to the 1. Down here, we'd be able to distinguish it a lot more easily. So 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, all the way up to 2. On the other side, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9. You can see there's a lot of room to play with in here. So on this first number line, we're looking at whole numbers. We're looking at counting by ones. Excuse me. Down here, we're actually, all the tick marks are going by 0.1. Which means that if we wanted to get as close to 2 as we can, our values would no longer be 1 and 3. On this scale, the closest we can get to 2 is 1.9 to 2.1. But why stop there? We can repeat the process, because as close together as these things are, there again is a bunch of space in between them. There is a lot going on in there. It's all a matter of perspective. So what if we blow this up so that 1.9 and 2.1 are as far out as we go? In this case, we can mark in between 1.9 and 2 if we count by hundredths. 1.91, 1.92, 1.93, 1.94, 1.95, etc. 2.01, 2.02, 2.03, etc. Again, what we can see is that the tiny interval that we had up here is quite broad if we are willing to change the scale of what we're looking at. at this level, we can get much closer to 2 using 1.99 and 2.01. To give you an idea of what this looks like on the original number line, 1.9 would have been about here, and 2.1 would have been about there. 1.99 and 2.01 would be so close to 2 up here that they'd be indistinguishable. So it is all a matter of perspective. Next, we will look at how we actually build a table of values using the calculator to establish what exactly is going on with this function.